Steam at an initial enthalpy of 100 kilojoule per kilogram and inlet velocity of 100 meter per second enters an insulated horizontal nozzle. It leaves the nozzle at 200 meter per second. The exit enthalpy is, so we need to calculate the exit enthalpy in kilojoule per kilogram. Now in the problem it's given that it's an insulated horizontal nozzle. So let the entry point be 1 and the exit point of the nozzle be 2. So from any datum line, let's say this be the datum line. Okay, so let's write here datum line. Now for this nozzle, if we write the steady state energy equation, so from the first law of thermodynamics, we can write from first law of thermodynamics, so the steady state energy equation can be written as Q minus W is equal to change in mass, internal energy at the exit plus kinetic energy at the exit plus the potential energy at the exit plus the pressure energy minus the internal energy at inlet plus kinetic energy at the inlet plus the potential energy at the inlet plus the pressure energy at the inlet. Also we know that enthalpy is equal to internal energy plus pressure energy. Okay, so if we substitute it here, this U2 plus P2V2 we can write H2, and U1 plus P1V1 we can write H1. Okay, now since the equation we are writing is for a nozzle and it is insulated, so this will be equal to 0, heat transfer is 0. Also there will not be any work done, so this will also be equal to 0. Because it's a horizontal nozzle, so the potential energy at exit will be equal to potential energy at the entry. So these two terms will cancel out each other. Therefore from here we can write the steady state energy equation as H1 plus C1 square by 2 is equal to H2 plus C2 square by 2. C1 and C2 are the velocity at entry and exit of the nozzle. Now from here we can calculate H2. This will be equal to H1, that is enthalpy at the entry, which is 100 kilojoule per kilogram. So let's write in joules. So 100 joule, 100 into 10 to the power of 3 joule per kilogram plus C1 square by 2. C1 is 100 square divided by 2 minus C2 square by 2, and C2 in the problem is 200. Exit velocity is 200 by 2. So from here we get H2 will be equal to 85,000 joule per kilogram. So this will be equal to 85 kilojoule per kilogram. Okay, so the exit enthalpy will be 85 in kilojoule per kilogram. To get more information on nozzle flow, you can refer to the NPTEL course, lecture number 17, nozzle flow, isentropic relations, area velocity relations, choked mass flow rate on aircraft propulsion by Professor Vinayak N. Kulkarni of the Department of Mechanical Engineering, IIT Guwahati.